Hello everyone, welcome to the next lecture on the PY questions. Today we will discuss about integral equations. We will cover all those questions from the year 2021 to 2023. We will solve this with the help of the shortcut trick. This is the part 1. Myself Dr. Garg, you can simply follow my YouTube channel where you can find all those previous year's questions related to the CSIR net, and you can simply scan and join this my WhatsApp group for the discussions. So I can quickly tell you what we will discuss in this. We will learn how you can solve the integral equations with the help of the shortcut tricks. In this video, we will see the 25 plus questions related to this integral equations, and we will see the next part, but it's the part 2 as well as the part 3 where we have discussed more than 25 plus in each video. So what is the shortcut tricks for you? I will quickly recall you what is the meaning of this. So whenever there is a question related to the integral equations, that is a Volta or the Friedel equation, I can classify into the 3 categories. First category is when the limits is of 0 to x, that is a lower limit is 0, upper is x. Second category is when the limits are my constant. Third category is when the limit is not constant or not from the 0 to x, but it is from a to x. Then how you can solve this? In this lecture, we will see all those questions from the year 2021 to 23 related to this type 1. After that, we will see this in the type 2 and this in the type 3. How you can solve this? I will tell you very simple shortcut tricks. That is, we can use always the Laplace transformation. That's one of the easiest way you can get the answer within a 15 seconds. Let's see this. Or when you have this kind of this, we always use the derivative rule. I will explain you this in my part 2 video of the integral so that you can learn it very simple manner. In the brief, what we can do in this, I will try to convert this equation into the system of there. Ax is equal to b, and then you can simply use the eigenvalue. You can get the answers within a fraction of a second. So let's start with this one. So whenever there is a question related to the non-homogeneous, that means f of x is a non-zero. Whenever f of x is 0, we call as the homogeneous equation. So let's start with these questions related to the 2021 to 2023 on this. Now you can see the limits are from 0 to x. So take the Laplace transformation on the both sides. And how you can take the Laplace of this? By using the convolution theorem. What is the convolution theorem here is? This is the Laplace of the sine x, Laplace of the phi. Okay, so what is the Laplace of the x? We all know Laplace of the t is nothing but my 1 by s square. So it is my 1 by s square. Laplace of the sine is 1 over s square plus 1. Laplace of the phi. I can take Laplace of phi and Laplace of phi here. I can take the LCM. It will be s square over s square plus 1 of phi. Now can you find the value of the phi from here? It is L inverse s square plus 1 over s4. So I can written this number as 1 by s square plus L inverse of 1 by s4. Now you can see in between it's a plus, so this option is cancelled, this option is cancelled. Now what is the answer of this? What is the Laplace of this is t, or you can write in the terms of the x. What is the Laplace of this? I can multiply by 3 factorial, I can divide it by 3 factorial. So it is 1 by 6 of, so the right answer is t plus of is the right answer. Look at the another one. Again, you can see the limits are my 0 to s. So I can take the Laplace on both sides. Laplace of the g, Laplace of the 1, Laplace of the s, and Laplace of the g. Here is the Laplace of the t. So what is the Laplace of g? That's as such. Laplace of the s is 1 by s. Laplace of the t is 1 by s square. Laplace of the g. I can take this Laplace of g as here. So this is s square minus 1 over s square of Laplace of the g is 1 by s. So can you find the value of the g? So I can take this as cancel out. So it will be s over s square minus 1. What is that? This is cos hyperbolic t. This is the Laplace of the g. Now we need to find the g of 1. So what is the g of 1? Cos hyperbolic 1. What is the cos hyperbolic is? E raised to power t, e raised to power over 2. So it is e raised to power 1 minus 1 over 2. Or I can written as e plus. So but none of the answer is the correct, but we always look about the possible answer. So the possible answer is of this form is the right answer. Okay, again you can see the limits are from 0 to t, so I can take the Laplace transformation on this. So Laplace of the y, again this is the convolution, so minus Laplace of the t, Laplace of the y, Laplace of the 1. What is the Laplace of the t? I can take this as common, 1 minus 1 by s square. Laplace of this is 1 by s. So can you find the value of the Laplace of y? I can take the LCM and then cross multiply. It is s over s square minus 1. So what is the y? Again it is cos hyperbolic t. Now look about the options. Y is bounded. So what is the property of the cos hyperbolic? This is always unbounded. So the first option is cancel out. Look at this, is only one correct option. What is that? Periodic. Cos hyperbolic is always be a not periodic. It is unperiodic function. It is here. Now you can integrate of this. What is the integration of the cos hyperbolic over the real line? Minus infinity to here. This is sine hyperbolic t from infinity. So what is that? This is infinity, but it is, so it means this is the right answer. How you can do that? I can integrate dy over cos. I can written as cos hyperbolic is this. What is that? I can written this as e raised to power x, e raised to power 2x plus 1. So what is that? This is, if I consider e raised to power x as a y, so this is dy over y square plus 1. So what is the integration of this? Tan inverse y or tan inverse e raised to power. So limit is from r, that is plus infinity to minus infinity. So what is the answer of this? Pi by 2 plus pi by 2. That's a, what is the answer of this? Pi, which is less than infinity. So the right answer is D is my correct option. Again limit is 0 to s. So take the Laplace transformation of this plus Laplace of the t, Laplace of the y is 1 by 6 Laplace of the x cube. So I can take Laplace of y as a common, 1 plus 1 by s square. So what is the Laplace of this? This is 6 over s 4. 6 will be cancelled out. So what is the Laplace of the y? I can take the LCM, 1 by s square plus 1. I can factorize them. I can use the partial fraction here. Now what is the y is? L inverse. What is the Laplace inverse of this? What is the Laplace inverse of this? So this is my t and this is my sine of t. Now look at the options. Now you have to do what you can do. So this is the odd option. So I can start from here. So what you can do? You can derivative them. Take the partial derivative with respect to x. So it will be here. Cos sine will be my cos x minus s plus, I can take this x minus x is a 0, and when you take it as a 0, so it will be here. Again take the second derivative with respect to x. This is minus s sine x minus plus, when you take upper limit it will be x cos 0 1 and 0 will be 0. Now this is my y, this is my y dash. So if you add them, you can see this number will be cancelled out. It will be x. Fine. Now what will be the answer of this? You can see this is c1 cos x, c2 sin x. What is the value of the y of 0? What is the initial condition for this problem? y0 is 0 because limit is 0 to 0. What is the y dash? 0, 0 to 0, 0. What is the y double dash? Is a 0 to 0, 0. So whenever y dash is 0, it means c1 is 0. So you will get as a c2 sin x. And because of this x, what is the answer of this? What is the particular integral? So particular integral is x. So what is the right answer of this? c2 sin x plus x. You can see it's clearly matched them. If you take the first derivative 0, you will get c2 as a minus 1. Because this is the s cube, it can never be as of the polynomial degree. So that's why this is the answer. The rest all options are cancelled. Again, this is from the 0 to t. I can take the Laplace of y. Laplace of this will be 6 over t raised to power 4. This is the Laplace of the sine and Laplace of the y. So what is that? I can take this as s square over s square plus 1 Laplace of y, this is 6 over s4. So what is the y? L inverse. I can take 6 s square plus 1 over s raised to power 6. I can take it as a separate. So y is L inverse 6 over s raised to power 4, 6 over 1 raised to power s6. So what is that? This is nothing but my t of cube. What is that? This is t raised to power 5 over 5 factorial. Now you want to find the y of 1. What is the value of the y of 1? 1. 6 over 5 factorial. What is the 5 factorial is? 120. It is 1 over 20. So the right answer is 21 over 20. Again, it's a 0 to t. If I take the Laplace transformation, it will give you the Laplace of the f into Laplace of the g. F is given to here. So what is the Laplace of the f? 1 over s plus 1. What is the Laplace of the sine is? S square plus 1. Now we can take the options and check their answers. Look at the last option. What is the Laplace of e? 1 over s plus 1. Laplace of the sine is here. Laplace of this. So clearly says that when you take the LCM, denominator is fine. Denominator is fine. But we need a numerator as a 1. But nothing is to be calculated, is cancelled out. So this option is cancelled out. So if I take this part, 1 by 2 minus 1 over s plus 1 plus s over s square plus 1 minus 1 over, and this is s over s square plus 1. What is that? Half minus 1 over s plus 1. If I take this as LCM, s square plus 1. So if I take the LCM as there, it will be minus s square minus 1, 1 minus s square. It will not be cancelled out. So this option is also cancelled out. Look at the first option. Half 1 over s minus plus 1, 1 over s square plus 1, and minus s over this. Now if you clearly see that if you take the LCM, it will be 1 s square plus 1 and 1 minus s square. It will be cancelled out. It's a 2 will be cancelled out. So the right answer is here. The rest options are cancelled out because this only the one correct option is there. Again, it's x minus t whole square. So again we can take the Laplace. So it is the Laplace of the t square, Laplace of the 5. What is the Laplace of this is? 4 factorial s raised to power 5, 5 factorial s raised to power 6. So it's a 1 over, what is the t square? It's a 2 over s cube, Laplace of the 5, it's my 24 s raised to power 5, 120 s raised to power 6. So what is a 5? You can multiply them. It's 12 L inverse s square plus 60 1 over s raised to power cube. So what is the answer of this? What is the s square? Laplace of the t plus 60. What is that? This is t square over 2 factorial. Fine. So what is the answer of the phi of 1? So that's a 12 plus 60 over 2. That's a 30. So it is 12 plus 30, 42 is the right answer. Okay, look at this differential equation is given to you, and we can start with there which of the is. So there's one right answer. We need a second derivative. So we will start from the first option. What is the first derivative of this? This is 0. How you take the first derivative? That is how you take this derivative. That's a partial derivative of this. So what is the partial derivative of this is? Minus t times y of t plus, if you take upper, t minus t will be 0 when you take the derivative of the 0 as here. So it will give you minus of this. Fine. If you now we need a second derivative, take the second derivative, it will be minus, partial derivative will be 0 plus, if you take the upper limit, x y of x, x derivative 1 minus 0. So what is that? Y double dash minus x y of x, but it is x, so it means it will not be the correct option. So this option is cancel out. This is the partial derivative. Sorry, this the partial derivative is, what is the partial derivative? Is a 1. It's a 1. Sorry, it's a 1. It's a 1 means if you take as a x, it is a 1. So it is a 1. So it's a minus, it take as a plus is 0. So it matches them. Now we have to check the limit. What is the y of 0? 0 to 0, it's a 0, it's a 1, satisfied. What is the limit of the y dash? 0 to 0, it's a 0, satisfied. So it is the right answer is here. If you look about the last option, what is the y dash? 0. If you take the derivative, 1. And if you take x is a 0. Again you can take the second derivative, 0, it's a 0, it's a y of x. But we need a y double dash plus y, it's a y double dash minus y. So the right answer is only first option. Okay, again we can take the Laplace. So Laplace of y, this is a constant number. So what is the Laplace of the constant? That's a k by s. So y of 0 by s plus, what is the Laplace? Now there is not a convolution. So what is the Laplace of integration? That is 1 over s Laplace of the y. So 1 over s Laplace of y. So we can take this Laplace y common, s minus 1. Laplace of y is y of 0 divided by s. So what is the y? It will be cancelled out. So L inverse y of 0 over s minus 1. So that is y of 0 e raised to power. That is my solution, y of t. Now we need a square. If I take square on this, a plus b whole square, this is my square, you can see the fourth option is the correct one. Now we can substitute one by one here. What is the y square? So if I just consider y of 0 is say alpha. So what is that? This is alpha square e raised to power 2t. Y of 0 is alpha, so it is my alpha square. Y square, so it is my alpha square e raised to power 2s ds. So what is the integration of this part? So it will be alpha square outside e raised to power 2t minus 1 over 2. So you can clearly say that it will not, LHS is not equal to RHS because of this 2. If this 2 will be cancelled out, then it is equal. It means this option is the correct one. If I take as a 2 here, if this I take here, it will be cancelled out. Alpha square will be cancelled out. Alpha square here, it means this is the correct option. This is the correct option. Again, this option is cancelled out. Why? Because left hand side is alpha square e raised to power 2t. This is alpha square. What is the integration of this? Alpha is outside, e raised to power t minus 1. It will not be cancelled out. So this option is cancelled. Similarly this. So B and D are my correct options. Okay, look about this one. Again, it's a 0 to x. So we will take the Laplace of this. Laplace of f. Laplace of the f. This is the Laplace of the sine into Laplace of phi. Now I can take this one as a common. It is a s square over s square plus 1 Laplace of phi. This is Laplace of f. So what is the phi? L inverse s square plus 1 over s square Laplace of f. I can take as a separate. So it is Laplace of the f plus Laplace inverse 1 by s square Laplace of the f. What is that? This is f. What is that? How you can solve? This is a double integration 0 to x Laplace inverse of this f of t dt. Now look at the options. Now there is a double integration. We need a one time integration. So we all knows how you can solve this integration. This here of this is nothing but x minus t raised to power n minus 1 over n minus, if this is my n of f of t here. So it is n is my 2. So what is the meaning of that? This is, if n is my 2, it will be, so one integration of this, n is 2, it is 1 over 1 factorial here. So you can see which one is the, which one match with this, f plus x minus t plus. So this option is cancel out, this cancel out, this cancel out. Only the right answer is my here. Okay, what is that? Px is a polynomial of degree 2. Again the limits are my 0 to x. So again I can start with the Laplace. Laplace of the p. This is again sine. Laplace of p. So I can Laplace of the y. So it is s square of Laplace y is Laplace p. I can find the value of this is L inverse S square plus 1 over S square into L of P. I can make as a separate L inverse of P, L inverse S square of LP. That's similar to the previous one. This is a polynomial. I can double integration, so I can simply write as x minus t P of t of dt. Fine. Now you can see the required options. Yx is a polynomial of degree less than equal to 2. Px is the degree 2. So when you take this as of the degree 2, when you multiply this by x, it will be becomes of the degree 3. When you integrate them, it will becomes a degree 4. So when you take this as integration 4, this as a degree 2, so the sum of the polynomial degree 2 and polynomial degree 4 is my degree 4. So it will not be here. Now look about these second and third and fourth options. If a1 is my non-zero, that is this number is my non-zero, so if I consider a1 is any number, say 1, and a0 plus of 2a2 is my 0, this sum of them is 0. So if I simply take a0 is 0, a2 is my 0. So again, what is the polynomial? P of x is nothing but x, which is a non-zero. So what is that? Y dash. So what is that? I can take the derivative of this. So what is that? So what is that? P of x is my x. I can substitute here. So y is equal to p is my x, x minus t of p is my x. So if I p of t, this is my p of t. Fine. Now if you integrate them, it is xt. So x t square by 2 minus 0 minus t square. So that's a cube. So cube means that's x cube by 3. Fine. Now what is the meaning of that? Y dash. If you take the first derivative, it will be 1. It will be my x cube. So it is at the point 0, it will be 0. It is 0, but y dash is not equal to here. What is the second derivative of this? The first one is a 0. It's a x cube by 2. What is the second derivative? First derivative is here. Second is 6x by 2 minus, what is the second derivative of x cube by 3? First is 3x square by 3. Second is 6x by 3. At the point 0, it is my 0. Right answer is C, B and D are my right. You can simply take these values as the sake of convenience. Okay, look about this one. Here you can see the limits are my 0 to x, but the function is not in the form of t minus x or x minus t. Here you can see all those previous values. This is the x minus t. In the previous case, this is x minus t. In the previous, this is not be there, so there is no convolution. This is a convolution. This is the convolution because of x minus t, and so on. Whenever there is x minus t, then only you can apply the convolution. But in this case, it is not a convolution. It means you can't take the Laplace transformation on this problem. Then what you can do, you can simply take the partial derivative with respect to x on both sides. So what is the answer of this? When you take the partial derivative of x, it might 2x phi of t, plus when you take x as a t as a x, it will be 0. So that's a 1 phi of x, and it will be here. So right side is my x. So now it's integration with respect to t. So minus of 2x will be outside. It is x phi of t plus phi of x is equal to x. Now I can take, this is 0 phi of t dt plus phi of x by 2x, it's a minus, and it is minus 1 by 2. Now you can again differentiate, because I can change this. If you take integrate, again differentiate, this will be 0, but it will be my phi of x. It will be my u over v. So I can take the phi dash over 2x and minus plus phi over 2x square. It is my 0. So I can take phi as a common, 1 plus 1 over 2x square, and here is phi dash over 2x. So what is that? I can simply write this as phi dash over phi, and I can multiply this 2x plus 1 over x. Now you can integrate them. Left hand side left hand side is x square plus log of x, right hand side is log of phi. So what is the phi? E raised to power x square into x. This is the right answer of the phi. Now you need a root 2. So what is the answer of the root 2? E raised to power 2. This is the right answer of this problem. That's a very simple concept about that. Remember, convolution is not applicable, then you have to use the derivative rule. Okay, again, now you can see this is x minus t, this is x minus t. So you can apply the convolution. Limits are my 0 to x. So apply the limit, apply the convolution or Laplace. Laplace of the 1 is 1 by s. Laplace of the s is s square. Laplace of the 4 is my 2 over s cube. What is that? This is plus. Laplace of the 3 is 3 by s. Laplace of the 6t, this is my 4t square. Laplace of the 6t is my 6 by s square. Laplace of the 4 is 2 times s cube into Laplace of phi. Fine. So this is Laplace of phi, this is Laplace of phi. I can common them. 1 minus 3 over s, 6 over s square plus 8 over s cube. Laplace of phi. I can take this as s cube as LCM, s square, 2s square minus 8. I can take this as LCM and I can find the value of s cube is LCM, s cube is LCM, cancel out. So s square, this is s minus 2s. So it will be s cube minus 3s square minus 6x plus of 8. Now how you can solve them? Clearly says that in the denominator s1 is a factor. So here. So how you can divide them? I can use the Horner method. Minus 3, minus 6, 8. 1 is there. So 1 minus of 2 minus of 8, 0. So the denominator will be s square minus 2s minus 8. Denominator and numerator are same. So it will be cancelled out. So what is the phi? 1 over Laplace of phi is here. So what is the phi? E raised to power t. And you need a phi of 1. What is the phi of 1? This is the right answer of this problem. Okay, look about this one. Now in this case you can see the limits are from a to x. So it means this is not by using the Laplace transformation. So what you can do? You can do the derivative with respect to the x. So on the left hand side, what is the derivative of this? K x comma y phi of y dy plus, when you take the upper limit as here, so it is my k x comma x phi of x into 1 derivative of this minus 0. Right hand side is my f dash. The integral can be transformed into this. Now you can compare them. You can see integration is a to x phi of y phi of y. So what is the meaning of that? G is my partial derivative of k x comma y. This is the first property. Right hand side is g, right hand side is f. So g is my f dash. Second property, the coefficient of the phi is my 1. Coefficient of the phi is my kxx. So kxx is my 1. This is the third comparison. That's all. Now you can see g is equal to f dash, satisfied. G is 1, but this is not true. K of xx is 1, that's satisfied. G is equal to f, that is not satisfied. G of xx is 1 over kxx is 1, this is 1 over 1. Partial derivative, that's satisfied. G is f dash over 1, that's also satisfied. Kxx is 1, that's satisfied. F is satisfied, this is also satisfied. So the right answer is A and C are my right answers. So I hope you can simply learn the very simple shortcut tricks by using the Laplace transformation. We will see the second part when the limits are my constants or the limits is from a to x in our next lecture of this 2011 to 2023 papers. I hope you can like, share and comment on my videos. Best of luck students. Happy learning.